Hello, this video is about animation. The last time we saw shapes and colors, and that wasn't all that exciting. I mean, you can make pictures, but we're in a computer science class. We should be doing something that's interactive, that performs some behavior, and just pictures on the screen don't perform any behaviors. So we're going to start there with that ellipse. Let's put it 50-50. It's 75-75 large. And we're going to need to change our size of the window because it's not going to fit. Well, it does fit. Why does it fit? Okay, it fits because XY 50-50 would be exactly the center of 100 by 100 window. And 75 width and height still leaves 25 pixels left over. So it just barely fits. Just to prove that, I'll change 100 to 100 and it'll just perfectly fit because the width and height will match the size of the window. Okay, but in any event, there's not much space for it to move around, and this is just a tiny window. I don't know why you'd ever use a 100 by 100 window. Let's go 800 by 600. Now, oh, not setup, sorry, size. Now, 50-50 is going to be pretty much the top left. The center of the window would now be 400, 300. So if I wanted it to be there, 400, 300, and we should. Okay, but in any event, we need to move this thing. And we'll learn later how to move it with your mouse and keyboard and all that sort of stuff. But for now, we're just going to have to figure out how to move it by, by an algorithm, by a specific formula. I can't interact with it, but it'll still move. And what's going on here that's hidden from us at the moment is it's actually drawing one static image and it just stopped. The program's not doing anything anymore. We need to change that behavior. We need it to draw multiple images, otherwise known as frames. So like in a game where you have 60 frames per second game and it's, fluid, we need to draw 60 frames per second or 30 or whatever that looks nice. And on each of those frames, the ellipse might be in a different position. By doing those frames and the ellipses in different positions in the frames, it appears to move, kind of like a flip book. So very much the same way games work. But we're going to have to slightly change the structure of our code to tell processing that this is what we want to do. Because if you just write it like this, as we've done before, it's drawing the one frame and it's quitting and it's still showing it to you, but really nothing's going on. The way you change that behavior is you tell it explicitly, I need to draw multiple frames. And specifically, what's going to be drawn is an ellipse. So we need to write what are called functions. We're using functions, ellipse and size, but we need to write our own functions. And specifically, we need to write two functions called setup and draw. And the way you write functions is, at least for the moment, you say void. That will be different later. Draw, parentheses, squiggly brace. And then usually you want to indent, or not usually, always you want to indent whatever is inside the function. And size will be in setup, not draw. And the difference between setup and draw is that setup occurs when the program starts, when I hit the run button, and that's the only time it occurs. It never does this command twice. Draw is for every frame. They could have called it draw frame to make it more clear, but they didn't. It's just called draw. This is what happens 60 times a second. So whatever code you got in here is going to repeat itself lots of times. So at the moment, this ellipse will still appear to be static because it's always at 400, 300, and size 100, 100. So it is technically doing 60 frames a second right now, but we can't tell. And you're not going to be able to tell if you don't use yet another feature of this language called variables. A variable takes the place of this number and this number if we're going to move it. 400 is always 400. It's never any different. It's just a static number. So instead of that, let's use a number like x and y, and we'll define what those are someplace else. Then when draw happens 60 times a second, each time it'll say, okay, what's the current value of x? That's where I'm going to draw the ellipse. So the value of x can change over time. That's the trick to make animation happen. You have to first give the value of x. So I'll give one example here that's wrong, but it's important to show the difference. I'm going to say x equals, what was it originally, 400, and y equals 300. I'm going to say that right here. It's not the correct way to say it quite yet. If I'm saying x the first time, it's the first part of the code that ever mentions x, you need to say what kind of thing x is. And we have different kinds of things, different kinds of numbers, different kinds of words, and so on, colors and so forth. X is an integer, so negative numbers, 0, positive numbers, but not fractions, not decimal numbers. So -1, -2, -3, 0, 1, 2, 3, and so forth. So integers, so you say int. Pixel coordinates are often just integers. 400, 300, x, y, good to go. It still looks static though, because even though I use variables, x is always 400, y is always 300. So I didn't really get very far by switching to x and y. They're still the same numbers all the time. Thus, if we change them, y equals y plus 1, well, now they're different. First, there were 400, 300, and I drew the ellipse. Then I have a line of code that says, okay, after you've drawn the ellipse, make x equal to something different. So x equals basically means update the value of x, change the value of x. And on the right side, that's what I want to change it to. So to go from 400 to 401, and then save that back. So now x is 401, and y is 301. So finally, I have something changing. Then the draw command will happen again, because it's 60 frames a second, and it'll happen at the next 60th of a second, and it'll draw the ellipse again at the xy. But it still appears constant. It's not going anywhere, because when the draw happens again, it comes back around and says, okay, let's reset x to 400, draw the ellipse, and then make it go to 401. Back again, let's reset x to 400, draw it, go to 401. It never really makes any progress. We never actually draw an ellipse at 401 because we keep resetting it. And actually, technically, x doesn't exist outside of these braces, these brackets. That's called the scope. A variable has scope. That says where the variable is known to exist. Brackets define scope. So x disappears once this function finishes before it comes around the next time again. It makes x, draws, increases x, then x ceases to exist. That's not very useful for animation because this thing can't go anywhere because I keep resetting the value. So let's not reset the value every frame. Let's actually make the value grow over time so that each frame sees the next value and the next value. The way you're going to do that is you just have to move these things out of here. You got to move them someplace where they don't cease to exist. So you got to change their scope. I'm just going to cut this and paste it. You can put it here, but often we're going to put it at the very top. And we don't need to indent up here. So if I define them up here, I can use them anywhere else. Because they're defined at the very top. Their scope is global. They're visible everywhere. So what's happening now, before the program starts, x is 400 and y is set to 300. Nothing else has happened. We just have these two variables now. Then setup happens, and again, setup only happens once, which establishes the size of the window. So it happens too quickly to notice, but when the program starts, the window will suddenly pop open and there'll be no ellipse yet. That's because it ran the setup function. When it's done with that, it can finally start doing the frames. And for the first frame, it comes into here and says, okay, draw an ellipse at xy 100, 100 width and height. Well, what's xy? It has to look at the rest of the code to see what is xy, what am I referring to here? And it finds it up top here. At the current moment, the first frame, x is still 400 and y is still 300. So the first ellipse is drawn at 400, 300. After that ellipse is drawn, but we're still in the first frame, the first 60th of a second of this program, x goes to 401 and Y changes to 400 or 301, and that frame is finished. Then it comes back around and starts another frame and says, draw an ellipse at XY. Now it reflects back and says, what's the current value of X? It's no longer 400 because it changed. It's the same X, but it now has a new value. And that's the value it's going to use. So now it's going to use 401, 301. And it will change it to 402, 302. Come back around. It's going to draw it at 402, 302, and change it to 403, 303, and so on. And then those values are just going to keep going up. Eventually, it'll just go off screen. And, the values get larger and larger. X goes to thousands, Y goes to millions. But it's so far off screen, we don't see any ellipses. Let's run this program. There it goes. We finally have animation. There's a few things wrong, but it's moving. Frames per second, it's moving. We can change the frame rate, by the way. You want to do it in setup because you want to make it the frame rate for the entire program. You don't want to change the frame rate per frame, probably. Let's do much slower. So there's the difference. Normally you don't change frame rate because you want it to be smooth animation no matter what you're doing. If you want a slow animation, just make X and Y go up by fractions, which means you're not going to use int. Let's actually do that. Let's go back to a normal frame rate. I'll just get rid of this. I don't want to go up by 1 each time because that kind of dictates the speed. Well, we can make it faster just to see what happens there. Let's go by 5 each time. Clearly, it's going to be faster. So, but if you want to go by less than 1, you want to go by fractions, then you're going to have to do something slightly different here. It's not happy about adding fractions to integers because that doesn't make any sense. Integers are 1, 2, 3, 4, 5, not fractions. So we can't use integer. We have to use something called float. And now it's happy. Float just means that there's a decimal point, and internally, the way it keeps track of that decimal point is it changes the number so the decimal point floats around. It can be in different places at different times. It's not really important to us, but this is just a word we've used for decades in computer science and programming to describe fractions or decimal values. So don't worry about it too much. But float is decimal values, int is integers. And if you want to keep track of partial pixel coordinates, like fractional pixel coordinates, to make this thing move more slowly, you got to use float. Now you'll see it moves slower than it did when it went by 1. And that's how you can get smooth animation that's slow without changing the frame rate, because you probably don't want to change the frame rate. And if you try to change the frame rate to something like 120, it might work, but also your computer might not keep up, so it just does the best it can. Okay, it's moving, but it's dragging. You can see the old positions, right? This thing is not erasing where it used to be. And the way we do that is a trick. We don't actually say erase your prior position. We just blank out the screen each frame. So it's kind of like the difference in a flip book. If each page is clear, you're going to see everything below it too. But if each page is white, like it got bleached, then you're not going to see the pages underneath. So the way we do those white pages is we put the background command. What you want to do is clear the screen or fill it in with some color, say white, before you draw the ellipse. So every frame it starts blank again. The ellipse changes its position, but it's on a blank background. So there's your more typical concept of animation. I'll make this a little bit faster just because I want to. There it goes. All right, so the point or the technique of animation is you got to have variables. There's simply no other way to do it, because if you're just using numbers, the numbers don't change. You have to use variables. And you have to, at least for processing, you have to do a setup and a draw. And the setup is where you want to put your size command, say how big of a window, and perhaps some other things in there, like frame rate if you care. But the frames are going to come from the draw command. Whatever it is that you want to draw on the screen, needs to be in the draw command somehow. If it's not in the draw command, you probably won't be seeing it. Variables you can use in the draw command, but you don't want to create them. You don't want this code in the draw command in most cases, because it's going to reset those variables every frame. And if you're resetting the variables, they're not changing. They're always back to 400, 300. So if you want them to grow over time, you need to make them exist outside of the draw function. They need to exist at the top in a global scope. Anywhere you see a number, you can use a variable, not size, because the size doesn't change. So what's the point of using a variable? But this width and height, you can use variables there too. You can change the colors and so on. So the assignments that we do, the projects, the labs, will use variables in various positions, and we'll do various examples in class with different variables in different positions. And it gets really interesting at that point because the color can change as the thing moves around, the size can change, and so forth. And later we're going to also see how to look at where the mouse is, or look at keyboard keys to see where, basically control the position with the mouse. So if you want the ellipse to be under the mouse at all times, you have to look at where the mouse is. That's just another variable. It's not a big deal, but we'll learn that later.